run it through your planer to do it right, so it don't snipe, okay? So, anyway, what I do is I lay out my design and I lay out my base for what I want in diameter. Now here I have, it says here I have a 6-inch base, 6-inch diameter base. What I've done here on my bowl is I put that bowl in half, so this is center line. You're only looking at 1/2 of it. So when you do your calculations, if you come out here to 3.5 inches wide, it's actually 7-inch diameter bowl. Does that make sense? You're doubling that. So this, if you look at the sheet that I gave you, on the segment, A is the length of your segment. That's the length of this segment here. Let's see how to work this. This is the length of your segment, the top length of it. That's A. And then C is the depth. And then B is the thickness. So, as you build up, I try to go out at least 1/4 of an inch or 1/2 inch on each side of my design of my bowl. And then the next one is, it may be the same length on A dimension as the next one, but as it gets wider, you're increasing that length. You're trying to maintain a distance inside and outside past your actual dimensions of your bowl. And you will find that typically I use 1.5 inch wide board, but when you get into bowls that go out further and then come back in, you're talking about a 3-inch width. You're trying to get it to swoop out. And it takes, because of the angle, you have to have a wider piece. And then it goes back in. Now here is, what did I do? Here is a picture. It's on my lathe. Yeah, you can pass that around. I typically do Southwest design bowls from Arizona or Texas, New Mexico. But that is called an Apache design bowl. And you will, a lot of times in that bowl, you will see, rather than making individual rings and then gluing the rings together, what I do is I will take, for example, a 3/4 inch piece of bovina, say 1.5 inches wide by maybe 3 foot long, and then I do the same thing. I'll get a thin piece of wingy and glue that on the top of it, and then I'll get a thin piece of maple and glue that on the top of it, and glue it all together. So I'm not making 3 rings. When I do my segments, I'm cutting all 3 pieces at the same time. If you try to, if you try to do 3 individual pieces, you get warpage. You can get warpage. And so I clamp these, and when I clamp the boards together, I'll use like a 1/2 inch board on the outside and a 1/2 inch board on this side, so I'm not putting any marks on the wood during the whole length. And it takes a lot of clamps to do that, but it works out. And let's see, when you glue the clamps, when you glue your pieces after you've got your segments done, you glue your individual pieces together, and then you put a clamp around them like this. Okay? And you leave that on there for about 2.5 hours. And then you can run that through your drum sander. Each side. Again, you have to run that through your drum sander. I'll pass this one around. This has not been run through the drum sander yet, but you can feel the ridges on it, why it won't why it won't mesh together, because you've got bumps in it.
Squeeze out. Is that squeeze out from glue?
Huh?
Is that squeeze out on the glue?
Yeah, squeeze out. When I glue the pieces together, I have a large piece of marble, and I put wax paper down, and then I glue my pieces, and then you can look at that. I've got numbers on the top of that, segments, 1, 2, 3 around for 12, so that when I'm gluing back together, they fit right. And before you glue it, you have to put it in your clamp, and you have to hold it up. And if you see any daylight at all, then it's not right. You can't see any daylight at all. Yeah.
What are you doing to clamp a ring as big as that one that you're passing around?
Oh, I have big rings.
Just using big.
I have bigger rings, and if it's not big enough, then I put 2 together.
Okay.
Now I get a lot of the clamps from people who work on big diesel trucks for their exhaust manifolds.
Okay.
You know, or their turbines. They're big, and then I put those together.
Gotcha.
Now, on talking about the segments, for example, if you want a 12-segment bowl, you take 12 and divide it into 180, okay? That gives you 15 degrees. So, if you're looking at 15 degrees on one side, you consider the other side, now you've got 30 degrees. So 30 times 12 equals 360-degree circle. Does that make sense? Okay. A lot of times, you go to a lot of shops, they have sleds. This is a 12-segment sled. Okay? And it fits on my saw. You can see where it runs in the tracks. Okay? And this is set up at 15 degrees. And I've done this with a digital protractor, and so that it's exactly on. If it's off at all, this is what happens. You can see daylight through this. You can pass that up. You can see the daylight cracks. And I just brought that as a sample. The nice thing about this is you got it set up for 12 degrees. Now I typically only use 12 degrees, but sometimes I will use 24, sometimes I will use 36. So once again, if you go back to your charts, if you want, I'm just going to say a 24, you take 24 into 180, that gives you a 7.5 degree miter. Gives you a 7.5 degree cut. So you have to have a sled that's 7.5 degrees here. Okay? I like this, but the problem is if I have to have a sled for every degree, I'll have 12 different sleds. And I've got no place to put them. So, what I've come up with, and it's called segmentology. I'm making this, I'm in the process of making this one right now. But the runner here will go into my table saw. And then I set this up. I have a complete set of these. 36 degree segments. 16 degree segments. 16 segments, 18 segments, 40, 32, 48, 24, and I've got a 12 somewhere too. I might have left that at home. But what you do is, you put this in there. I'll just use an 18 for example. You put this in here, and you line that up. You screw that down. You take this out, and that's it. In order to get your length, I have a magnetic base over here that stands up. And so my piece of wood will go in here and hit this until when it hits that, then I can slide it. I turn it over on this side, and then I do the same thing. You're never off. You don't have the issues of a little bit of a crack. This is dead on, all the time, all the time.
Where did you get the wedges? Did you make them?
I ordered them. The set is probably about, the whole set, I want to say it's like $75 for the set.
Precision.
Precision,
machine,
yeah, everything is precision done. Now, we had a couple people somebody made this one out of Horan, which is 15 degrees. But it's much easier to do this.
Can't be off a few thousandths with that.
You can't. I mean, really, a little bit of a crack, you think, oh, I'll get by with it, but then when you start turning, you see a little opening.
Wherever that crack is, it shows.
There, that crack has showed up, and you're saying, well, now I gotta use sawdust and glue to get in there and fill that in. And sometimes you can see that where you filled it in. So you don't really wanna do that. I mean,
Do you have to make two passes with the jig, one to cut the long edge and one to cut the short edge?
yeah, what you do, I wish I could have brought a piece. If you have, let's just say this is the width of your piece you're cutting, you put that in here like this, and you run that through your table saw, and that gives you your first cut. You then flip it over and bump it up to here, and then run it through. This right here determines the length of your segment, and you have to measure from here to where your saw blade is. That gives you your
Inside or
length.
outside of the saw blade?
Huh?
Inside or outside of the saw blade?
Inside. Wherever you're gonna cut.
So are you saying you use that jig and that jig?
No. I'm making this jig basically to replace this one.
Okay.
This one I've always used. But then I've got other jigs, I've got other ones like this, but different degrees.
So that would go in there like that, and you're cutting that edge.
No, I'm cutting this edge.
Okay, all right.
I'm cutting those edges.
Okay. Oh, I need to pass it.
Let's see. And you will see on this diagram here that this part right here is wider. I'm showing you like a ½ inch here and a ½ inch here, or an inch here and an inch here. Here I'm showing it more, 1.5 inches. So if I want to put a design element in there like that, if I want to put something with 2 or 3 layers in it to give me offset design, much like that Apache bowl here. All these segments are 3/4 of an inch thick, but so this maple, this Mabinga, and this maple ends up to be 3/4 of an inch thick. Does that make sense? I don't know. There's a questions?
I have a question about your sled.
Yeah.
I've been thinking about making a sled for my table saw, but I've got an older table saw, and the rails, right? They've got these little clip-looking things on them. It's an old Craftsman one, and like the little miter thing that comes with it. It's physically smaller than the gap, and that would cause differences in the angle of the sled, right?
Yeah. So what I do,
What's a really good way to
what I do is something like that. Well, if you use Argudo, which is like a Teflon, or even a board, to make your runner, what you do is you drill a little tiny screw in the end, on each end, and as you screw that screw in, it widens that board out so you don't get a wobble.
Oh, okay.
You don't get a wobble.
What did you say that material was?
It's Argudo, it's like a Teflon. I call it Argudo, but there's a different name for it. It's very much like Teflon, but it's a little harder than Teflon. They use it in a lot of food plants for runners on tables, for product going through.
If you bought a plastic cutting board that's kind of thick, it's high density polyethylene, and you could use that to make runners, that work really well.
Yeah, yeah. A lot of people, a lot of guys have even used corian, made corian, but you gotta be really on because you can't spread corian. You know, you can't split it.
Well, you can buy the runners from Rockwood, it's already got the screws in them that'll adjust in and out.
Yeah, these pieces here,
That's,
that's what these
that
are.
works fine.
That's what these are.
Right, yeah.
You can adjust these here to go in or out a little bit and it tightens up. And when you set this right here, what you do, when I put my runners in there, I've got my piece of Teflon in here, and I've got like a dime slots in my dimes in my slots or pennies in my slots, and I put the Teflon on top of that, and then I put a little piece of double-sided tape on that. I run this up against the fence of my table saw, and I set it down and I press it. Then that gives me my true 90 degree. So, the other thing that you really have to remember when you're doing this is to make sure that your blade on your table saw is exactly 90 degrees. If your table's here, your saw's got to be exactly at 90 degrees. If it's not, and you tilt it, your rings are not going to fit together. They're going to wobble, and you don't want that. That's a big critical part. I see a lot of mistake people doing that. Somebody will use the table saw, they want a different angle like on a stave. They want a different angle, and then somebody comes up, oh, I'd do this, and they start cutting, and they start going, oh, that's not working. What's wrong? And it's because that blade is not at 90 degrees.
Well, a good way to check it is if you're using 12 segments, cut 6 and see if they match up, and set right up against the fence on the table saw
Yeah.
and flat.
Now, the other thing that you can do is if you're making something like this, for example, and it's a little off, you can divide that at 180 degrees, and if you've got a wide enough flat drum sander, disc sander, you can push that up against it till it's square, do the same thing on the other, and then glue those two pieces together. Now, it'll have a little bit of wobble, but it'll work out. It'll work out.
The digital protractors, how accurate are they?
We're right on.
You could say,
I mean, if you get one from China, no. But if you get one from Starrett or somebody like that, it's gonna be right on the money.
so if you set your blade with that, you can be pretty sure that it's.
Oh, you're talking about that? No, I just use the standard square, a good Starrett square, you're all right. But I'm talking about if you're using a protractor here to get your angles here, then I use a digital one.
Okay.
It gives you a readout in thousandths of an inch.
So when you're doing a bowl that's tapered like that, obviously each ring has got to be a little larger diameter.
Right.
So you use the same angle of cut, but you just make the segments longer. To
That's
make the
correct.
ring. Okay,
That's
but
correct.
You don't ever change the angle of your segments in the same bowl. You maintain that same angle all the way up.
Yeah, but I mean,
The 8 dimension change.
you can vary, it's gonna vary, when you go out further, you can see how this one right here, this segment is much longer because it's going out further.
Why couldn't you just make a ball the same size as the long one and cut it off when you're?
You can't, let me show you.
Well, you change the length, all you do is just adjust the stop.
Yeah.
Yeah.
Pretty simple.
You can pass that, you can show that to him, see. The longer, the lower the bowl, the larger the radius, or the larger the diameter, you have to have longer pieces. So, it's hard for me to explain that to you.
Okay.
You're going at a much higher degree, an angle. It's versus going at 45 versus going at 20.
Right.
You know, so you've got to have a longer cut.
Okay, I see what you.
If you haven't done this before, would you say, would you recommend a certain number of segments?
12.
12, start.
12. 12 is the easiest.
So how long did it take you to perfect this?
Now, that's the obvious
A
question.
few decades.
I mean, I've been turning since 2006,
Wow.
and I turned with the Woodturners Guild out of Raleigh at North Carolina State University. And you pick up a lot of information from them. You know, from, like this guild here, you're gonna continually pick up. And when you have people come in to demonstrate, the things that they show you are just astounding. It just wakens you right up.
Do you pick it up in segments?
Yeah, you do.
Funny.
Well, it's like anything else, the more you practice it, the better you get at it. And like I said, Carl taught me how to set this up. And once I got it set up and got my angle set, I just leave it on the thing, hang it on the wall when I need it, pull it down, and just figure out what length. Basically, if you're looking at a 15-inch diameter bowl, I know now that I want that, and I'm gonna leave it 3/4 inch thick. I know that I'm gonna use probably 1.5 inch wide board to cut them from. And I just look at what length I need, set the length up, and then cut 12 of them, and you got your ring.
Is it fair to say you didn't get that right the first time?
What?
You
Is it
will
fair to say
find,
you didn't get that right the first time?
No, you didn't get it the first time.
you will find that on dimension C, when that increases, when your depth gets longer, it's much more critical that you be right on. You know, little pieces, they go together easy. I mean, but when you get into depth, it wants to vary a little bit. That's why it's got to be exact. That's why you go to segmentology.
I like what you do, but I ain't never, but on mine, so I just use a chop saw.
You can,
Yeah.
on a 12 segment or a different one.
Yeah, I mean, yeah, mine ain't, I've used, walnut and maple, you know, maple, that's just good stuff for me when I segment them together, but mine, that pine, you know, it's so small, I had to, that's the reason so many layers, but I just used chop saw, and then I didn't, at the time, I didn't have no clamps, so what I done was glued it up, I put a rope around it, and used a screwdriver and tightened it up until I got it where I was. And so I just, pretty primitive, but it worked.
Well, I started out with a chop saw too, but what I did was, I had a piece of maple, hard maple, and it was cut at exactly 15 degrees.
Yeah.
And when I put that up there again, then I brought my chop saw blade down, I pushed that up there, then I screwed it down tight. You know, so there wasn't any variance in it. And I did really well. But I still had times when I would be off a little bit.
Yeah, me too.
So I have a belt sander that goes this way and then a disc sander that spins. And I can sand a little bit and get that gap out. And then I glue it together. And that's why you number your rings, so that once you've got that up there and there's no light, you don't want to get your rings all messed up. So I number them 1 through 12, 1 through 24, so that it doesn't vary.
Yeah.
And you will also find too, that sometimes when you're gluing, it says, that's not looking right. If you flip one over, for some reason you flip one over, then it goes together. They're very touchy.
So it sounds like the kind of thing for people that like precision.
You've got to have a good sled. I mean, you can work around things, you know, but I was making so many mistakes, I kept this was off a little bit, and I kept having trouble. I told my wife, I've got to buy a disc sander so I can work that gap out. Well, then I spent more time on getting this right. I bought a good digital unit and set it up, and then I don't need it now. But with
Don't
this,
tell your
But you
wife.
got it though, right?
huh?
But you have it.
Yeah, I have it. If I do need it, I have it.
I saw this documentary about a shingle maker using a froe.
Yeah,
And what he did was he cut a strip of inner tube rubber. And he would put it around the log and maybe double it, but each whack, it wouldn't fall out, and he could just go all the way around it. the
Yeah.
log.
that's kind of like when you do stabs. Somebody did stabs here, right? The long way. Your table saw and your blade, you've got to be right on. So they have a unit tells you how many degrees it has to be right on. When you make those stabs, and the thinner they are, it's a little more dangerous because your fingers are right near that blade. So a lot of times when I make really tiny itty bitty pieces, I use a pencil with one of the diamond shaped erasers that you stick on the end of it for kids in school, and I use that to push that through. I mean, I don't do any of the metal. I cut the metal part off where the eraser was, but I use that because you don't want to hit metal, especially on a saw stop. You know, if you're using a saw stop saw and it senses that metal, you're going to blow the cartridge and you're going to ruin your blade. So it's $150 for a unit, and then plus the cost of your blade. You learn, and that's the same thing with moisture on the saw stop. You have any moisture in there, it's going to blow your cartridge.
Like how much moisture?
I would say you have to be at 7 or 8%.
Really?
Yeah.
Wow.
So Paul, the next time you're in front of us, what are you gonna be talking about the next stage?
The assembly and then stacking the rings and then assembling the rings, and I have a unit where, and I'll get some rings made up so I can show you how they go and how they stack and how you press them down and build it up.
Do you use a glue line blade?
A what?
A glue line blade.
I don't know what a glue line blade is.
Well, it cuts it, you can almost, with a saw blade, you can cut it and glue it.
So finer tooth.
Yeah, 30 teeth, is it 32?
Most of them are 50 or 82.
That fruit, yeah, I think it's about 30 or more tooth on it. Yeah, gives you
I don't know, all my saw blades for my segments are probably at least 60 or 80,
Oh, 82, okay.
yeah, 82, yeah,
Well, the main thing is if it's good and sharp, you don't need any splintering.
yeah.
Yeah, glue line, man, you can cut here and cut there and boom. I mean,
When-
if you don't have a joiner or something of that nature.
Yeah, it's really important that you keep your saw blades sharp. You try to start doing maple. When it starts getting dull, you'll start burning your maple on the edges.
Maple and cherry is burnt, you just look at it.
When you glue your ring together, you said you run those through your sander.
Mhm.
Can you run them through a planer and get them smooth enough, or
No, I run them through my drum sander.
you really need a sander to do that?
Yeah, and you can't use your drum sander as a planer. Now, I use 100 grit on my drum sander. Some people have used 80, but I think that's a little coarse. But you don't want to bear down. This right here will probably take me 4 passes maybe underneath my drum sander, 5 passes. Then the same thing on the other side. So I'm going to reduce the thickness a little bit. You got to be able to understand how much you're going to lose. But you run that through, drop it down, run it through again, drop it down, run it through again. You're turning, and then you do the same thing on the other side until you feel no bumps or no ridges at all.
That's a good point too, because you can tell more with your fingers than you can looking at it.
Yeah,
Fingers
yeah, you
all
can-
the way around.
Yeah, you'll feel it.
So does it require so much precision that each ring you would have to run through the drum sander the same number of times?
No,
No.
no, it's until you get the, I usually go to by, if you put numbers on each side, when the numbers are all gone, you don't see the numbers anymore, then it's pretty much taken care of. You know, pencil numbers.
Can I ask you something? I was reading something interesting. This guy seemed to know what he's talking about. He said, never ever use PVA, the yellow glue, PVA glue.
I don't use it, no.
He said, always use hide glue because you don't have to worry about squeeze out. You know, because you know how you get those ugly yellow streaks with yellow glue.
I use regular wood glue. That's all I use.
But what do you, hide glue or what?
No, it's not hide glue, it's
Tight bond.
tight bond, tight bond.
Yeah, he was saying.
Tight bond two,
Yeah, tap on it, yeah.
two, because tight bond two dries quicker.
Yeah.
Tight bond three takes a longer period of time to dry, but it's better from the outside.
Waterproof.
And food
Yeah.
safe, and food safe.
Yeah, and food safe,
Plus, in contrast to super glue, it'll move some if it needs to,
yeah.
whereas super glue will not. Your wood will crack first.
Now, they have that stuff at Lowe's, it's called rapid fuse. And I mean, you join two pieces together and you hold it 5 seconds and that's it. It's done. But you better make sure that all your, no gaps in there, because you're not gonna get them out. You need to be able to adjust the tightness on your clamp.
Well, tap bond 3 will give you a little more open time than tap bond 2.
Yeah, it takes it's a longer
Yeah.
time to cure.
Or yeah, not the cure, but when you're doing your glue up, the open time on the glue.
Yeah, but even dry time.
Well, yeah, but once you got it glued up and clamped, you know, it's dry.
I can usually, in 2 hours, I can usually take this band off and run it through my drum sander. As I start stacking my rings and gluing them up, 2 hours. 2 hours, 2 hours. And I typically will start maybe doing, depends on the size or whatever the bowl is, I can do 2 or 3 rings to start out with, maybe 4. And then start building out from there.
Just in the tight bond array of glues, you don't see it very often, but they sell one that's called extended open time. And that's what's on the label. It's not 1, 2, or 3. It's called
No,
extended
is
open
that the
time.
hot glue?
No,
Has a 20-minute?
no, it's just tight bond, extended open time. And when I'm making drawers with a lot of dovetails and things, and I want more time to put it together,
That's about